So now let's look at the end of that process of spending the $10 available to the consumer. So what we have here is just a small part of that table. And at the end, what we see is that the consumer's best off when they buy 4 ounces of granola and 3 Pop-Tarts. And again, based on the prices, we see that spends the full $10. So for the 4 ounces of granola, that costs $4. Each of the 3 Pop-Tarts cost $2, so a total of $10. The total utility then that the consumer derives is both the $4.40 from the 3 Pop-Tarts, but also the $3.30 from the 4 ounces of granola. And what we see is that's 770 units of total utility. And the big question for us is this the best that the consumer can do? So of course, the consumer could actually get more utility by, say, just buying another ounce of granola, but they can't afford that. So what this is really asking is, given the constraints that we have available, is this the most utility we can get? One easy way to approach this is to consider what happens if I make a change. Well, one way to change this allocation is to take $1 from Pop-Tarts and move it to granola. Well, what would that actually represent? Well, now that would be 2.5 Pop-Tarts and 5 ounces of granola. Well, what would we get from that? Well, you'll notice the 5 ounces of granola gives us 380 units of utility. Well, that's an improvement, right? It goes from 330 to 380. And you'll notice something, that's what? The marginal utility of 50. But in that same process, we not only get the 380 units of utility from the granola, but now we go from the 440 and we move back to 2, but not just the 2 because we gain 2.5. So we have the 320 plus half of that third unit, so 60. This is also 380. And the total here, 380 plus 380, is what? 760. And that is smaller. We didn't actually have to go through all of that process to get there. What you'd see is, as we go from 4 to 5, we gain the marginal utility. Over here, as we go from 3 to 2.5, we actually lose that 60 units of utility. So we gain 50, lose 60. That's a net change of minus 10. And you'll see our total utility went from 770 to 760. So what that tells us is that we can't increase our consumption of granola and make ourselves better off. Well, that's not the only direction that we could move. Instead of buying more granola, we could do what? Buy more Pop-Tarts. But what you'll see is that we have the exact same problem. Whereas if we buy more Pop-Tarts, what do we get? We gain this 45 units in utility, so we gain 45. But now in order to afford that, what must we do? We must give up that 60 units of utility, and so we have a net change of minus 15. And what you'd see is if you calculated the total utility of 3.5 Pop-Tarts and 3 granola, it would actually be 15 units less than 770, or you'd end up with 755 as a result of that. So the nice benefit that we get here is we can approach the problem on a marginal basis. We can just ask the question, as we're spending the $10, as we spend each dollar on the next best thing, what will we end up with? We'll end up with the combination that maximizes our total utility. And that's really good news, because for most of us, that's a very easy task for us. As we leave out into the world and we go to the store, or we're deciding to go to the movies or maybe play miniature golf, what are we really doing? We're making a change from our current position. And so we're asking that marginal question. How do we improve but spend the money in the best way possible? There's another thing that you'll notice here. As consumption of, say, Pop-Tarts goes from 2 to 3, what do we see? A Pop-Tart's good, right? It goes from getting 320 units of utility to 440. And so we gain an extra 60 units of utility per dollar spent. But what happens as that increases, as we go from not 2 to 3, but 3 to 4? You'll see that that marginal utility gets smaller. And the same thing happens with granola. We go from 80 to 60 to 50. So what's going on here? Why are these values decreasing? Aren't Pop-Tarts good? Yes. Isn't granola good? Yes. But they're not quite as good as the previous unit. This is what we call diminishing marginal utility. So as the quantity increases, the marginal utility that we're getting is still positive, but it's getting smaller. Well, what does that mean? That actually tells us that as we get more, the added benefit gets smaller. And that's important because what does it do? It makes other things around us look better. And as we approach this problem then of diminishing marginal utility, we do have one question. Does this thing ever go negative? Is it possible that marginal utility could be negative? For most goods and services, we're going to say no. More is always better. But it is possible that this thing could be negative. Imagine you're eating a piece of pizza. Well, and you're hungry, so you eat the first slice. That's really great. As you eat the second slice, that's pretty good. You eat the third slice, you're probably getting full. The fourth, the fifth. Eventually, you're going to make yourself sick. And so what would that do? That would actually lower your total utility. So it is possible these things can actually get negative. So as we do this process, we want to be a little careful. Most of the consumption that we deal with are in these positive ranges, and that's generally what we're going to deal with. So from this, now let's take a look at this in a broader context. And so limiting ourselves not just to this step-by-step model, but thinking about it using the idea of an indifference curve.